All right, let's go through some PowerPoint first. We really ought to kind of be past Chapter 2 and we're still in it. That's because the short assignments themselves are too much fun. So as we know, we can do things like A equals A plus B, or A equals A plus 2, or B equals B times 3. But you can also use plus equals. So this would take bank balance, and then this, bank balance times interest rate, those two would be multiplied by each other, and then they would be added back into bank balance. So I don't know why this has them more complicated, but we could just do, C plus equals 10. What does that do? It takes 10, adds it back to C, and stores it in C. So if C was equal to 20, by the time that's done, it's equal to 30. If you do C minus equal 10, then it takes C, it subtracts 10 from it, and stores it back. So if C was 100 at that point, it would then equal 90. If you feel like doing divided by, C divided by equal 10, that takes 90, divides it by 10, and then it would be 9, right? So this, if we start off with, int C is equal to 1, and then we do C, I don't know why I did a capital letter, plus equals 2, and then we did C times equals 3, and then we did C divided by equals 4. That's not going to work. That's not going to do what I want it to do. Divided by equals 6, and then C modulus equals 2. Let's see what happens. Let's do all those in a row. So we come in here, and C plus equals 2. C started off as 1, so what's C after that?
3.
Yeah, it's 3. And then we're going to multiply that by 3.
9.
So that's 9, and now we're going to divide it by 6. See, that's what I was trying to avoid. Because since these are integers, the result is going to be rounded down to be an integer. But so be it.
0.
It's going to be 0. Okay, that was dumb. I don't like that. Let's do C is plus equal to what's something that would get it to be divisible by. All right, we're going to change the game a little bit. All right, so that was 3, and then we add 15 to it, and it becomes 18.
No, you times it. Oh, sorry. What?
Times 6, and then divided by 9. Will that work? Yeah, let's do that. See if that works. Okay, so 3 times 6 is equal to 18. And then we divide it by 9, that's 2. And then 2 modulus 2 gives us a remainder of 0. Okay, so after all that work, we got it back down to 0. Then if we did C++, after that it's equal to 1. And if we did C minus minus, it's back down equal to 0. And remember that putting the plus plus in front of the variable does something slightly different than subtracting it. If it's on a line all by itself, it doesn't matter. But if it's part of an expression, the placement of the plus plus indicates whether it gets done first or last. So if you do this, x is equal to 3, y is equal to x plus plus. Since the plus plus follows a variable, it means it's the last thing that happens. So 3 gets copied into y. So at this point, y is equal to 3. And then x gets incremented by 1. So x is equal to 4. Whereas if we did it like this, x is equal to 3, y is equal to plus plus x. If the plus plus precedes the variable, it's the first thing that happens. So that gets incremented to 4. And then it gets copied into y. So they're both equal to 4.
In the book, it says something about and they also do like a little test, like a stopwatch test. I guess there's a stopwatch function in C#, but it shows them like side by side which one runs faster.
Yeah.
And the prefix one runs faster, but can you still use that in the for loop? Or would you have to change?
Yeah, the question is if preceding the plus sign runs faster than doing it as a suffix, and that was true of old versions of C++, and I'm surprised it's still true. But you could do either one. You could do this. For int I is equal to 0, I is less than 10 plus plus I, just as easily as you could do the other one. And they would both work the same.
Okay.
Why? Because this is effectively on a statement all by itself, so it doesn't matter whether I gets incremented first or last. And it blows my mind that one is speedier than the other, but apparently using the stopwatch function we could prove that they are. So that's totally legit, and if we have a suspicion that that's going to run a little bit faster, feel free to do that. I've taken classes where the professor said, yeah, back in the 80s his version of C++ did it faster, so he just always did it that. I'm just used to typing it this way. But maybe for the rest of this class I'll do it that way, just to change things up. The reason why that works is because a for statement is effectively just a while statement, right? So you could do I is equal to 0 while I is less than 10. Do some business, and then you could say plus plus I. Since that's on a line by itself, it doesn't matter whether it's the first thing or last thing that happens. So one's a prefix, one's a postfix. I love that term, postfix. Then there's the so-called unary operator, which just flips something to be negative. You hardly even think of that, right? I mean, if you say x is equal to -3, you don't think of it as being x is equal to 3 turned negative by the minus sign, but that's what happens. And then decrement, just like increment, is either prefix or postfix, following the same rules. So the Boole data type can either be true or false, and you can hold the results of an expression in it. If you do this, int temperature is equal to -40, -30, and then you do bool ice is equal to temp less than 32 degrees, then by the time we're done with this, ice equals true, because the temperature was less than 32. Typically, that's what you're going to use a Boole variable for, is to hold some kind of state information, so that later on you could, base an if statement or something like that. So if ice console dot, write, it's ice. So a comparison operator compares two items. It's a binary operator, meaning that it takes two operands, and then it returns a Boolean value. And we have several comparison operators. Our comparison operators would include, how do we compare values? We compare them with things like x is less than 3, x is equal to 3, x is greater than 3, x is not equal to 3, and so on. X is greater than or equal to 3, x is less, whatever. So if we're doing the comparison operators like that, if I'm correct, there are 6 of them. There's equals, there's not equals, and then there's kind of the polar opposites of each other. What's the polar opposite of x less than 3? It's not x greater than 3, it's x greater than or equal to 3. And what's the polar opposite of x greater than 3? It's not x less than 3, it's x less than or equal to 3. Because you have to include the middle value, right? Otherwise, if you worded something like this, if temperature is less than 32, and then you wanted to rewrite it using the same language, but with a not, if not temperature greater than or equal to 32, those would do the same thing, the exact same thing. And if you took the equal sign off, then it would behave differently on this one than it would on this one if the temperature was exactly 32. So just kind of remember that these are polar opposites. That's it. And so these are comparison operators. The only one that people aren't used to seeing is not equal to. And if you felt like it, you could reword it like this. If not x is equal to 3. That works just as well, but I'd rather see if x not equal to 3. My only warning is that the more nots you throw into an expression, the harder it is for the human brain to understand. The computer understands it just fine. So the Boole data type, do we really need to see an example of this? So the values for But then we have a Boolean variable called is 6 more. And we check, is 6 more than our value? Yeah, it is. So when we print it out, it says 6 is 6 more is equal to true. It always kind of bugs me to put the variable you're comparing against like this, 6 greater than value. I'd rather write value less than or equal to 6. That's just the way my brain works. It means the same thing, right? But it's the way my brain works. So arithmetic with variables or constants of the same type. The result is of the same type. But if you compare two variables of dissimilar types, C# chooses a unifying type for the result. You get an implicit conversion. It gets converted to the type with the higher type precedence. Meaning that if you're comparing floats and ints, they'll both be converted to a float before the comparison. So f is equal to 3.2, I is equal to 3, and then you do if f is greater than I. How does that work? Well, f is a float, I is an int. These are dissimilar data types. The computer doesn't know what to do, so the compiler provides some code which does an implicit conversion of the int to the float. You always have to go from the less complex type to the more complex type, because if you converted the float down to the int, it'd round it down. And now f would no longer be greater than I. It would be equal. So an implicit conversion or an implicit cast, it's a transformation that occurs when a value is upgraded, promoted, assigned a type with a higher precedence. This is the only text I've ever seen use the word precedence for that. But longs have higher precedence than ints because they're 64-bit data types as opposed to 32. Doubles have higher than floats, and it always just goes up the scale. Do we have a chart? No, of course we don't. Okay. So the precedence, the precision of them goes like this. Doubles are greater than floats, are greater than long, are greater than ints. So if you arrange them like this is why we can call it promoting. An int will be promoted to a long if need be. Ints or longs will be promoted to floats if need be. Ints, longs, or floats will all be converted to double if need be. Now, does that mean that the data is changed after I has been temporarily converted into a float for that comparison to work? Is I now a float? Nah, of course not. It's still an int. It's a temporary conversion just for the purposes of you doing math in it. And the same is true of any other kind of binary operator. If you do double x is equal to I times f, one's an int, one's a float, they cannot be multiplied. The computer doesn't know how to multiply dissimilar types, so the compiler provides a conversion. F is not going to be downgraded, demoted to an int. Instead, the int will be promoted to a float. Then we'll have two float types. Easy for the computer to multiply and to store into x. That's what's known as an implicit cast. You can do an explicit cast as well. If you want to take a value and you want to force it to fit into another value, you can do that. The C language, C++, is kind of loosey-goosey about it. It'll do implicit casts that lose data. This would be totally valid in C++. If you wanted to say I is equal to F, no, it'll go, okay, you're trying to stick 3.2 into 1, and I'm going to round it down to 3, and we're all good. Nah, we don't want to do that. Even if it's legal in your language of choice, don't do that. Instead, do an explicit cast so that you and the programmer who follows you know exactly what's going on. And an explicit cast, done like that. This says, okay, take my floating point variable, cast it, like reshape it like molten metal inside of a cast, to fit into an I. And will it round down? Will it lose data? Yes, it will. You do that when the compiler will not support the conversion. For example, if you have a double and it's equal to 3e to the 99, and then you have a float, let's make that 3e to the 299. And then for some reason you need to store that in a float. If you do that, This is larger than the capacity of a float to contain. A float cannot hold a number of that high of an exponent. You can go, okay, I really want you to do it, so you can cast it. And that says, it's my responsibility. I understand that there may be data lost, but for some reason I need that double to fit inside of a float. And you really only want to do that, if it's small enough to fit in there. But if it's not, it'll still do it without complaining. You just won't get an answer that you might be expecting. You'll get data overflow, meaning that the variable is probably negative when you thought it was going to be positive. Don't really need that name coming up every single time we're looking at this. So here we take the bank balance. It's a double. We divide it by 4 and we cast it to a float to fit into weekly budget. Why would we do that? I don't know. And then we take weekly budget and we cast it into an int, which would round it down so that we can store into dollars. So a character can hold any single character. You denote them with single quotes, unlike Python where you use either single or double quotes interchangeably for everything. This is common to C, C++, and Java. Single quotes are for characters, double quotes are for strings. You have to have something between there. You can't declare something that has, 2 apostrophes with nothing between them. It's text, though. It's not a number. It's stored as a number, but it's not a number. And what do I mean by that? It's an ASCII or a Unicode value. So if this is a capital A here, if we hit an ASCII chart, we would see that A is stored inside the computer as 65. But unless you cast it to an int, you're not going to be able to get that 65 out of it and do math with it. So all strings, all characters are ultimately numeric values behind them all. And I've done this in other classes. I haven't done this in this one, I don't believe. If you look up an ASCII chart, you'll see how to convert them. Now, this is just for the first 127 characters, the English characters. If you're using other languages that have other characters, German or, Nihonji or however you say, Japanese or whatever, there's obviously going to be characters that don't fit on the ASCII chart. That's what Unicode is for. C# is a Unicode compliant language. But the first 127 characters are the same as the ASCII chart. And they are what we are familiar with. So if we pop open one of these guys, I just Googled ASCII chart, we'll see that a capital A is a 65, and then a capital D is a 68. So if we wanted to spell bad inside the computer, or if we typed it in, we would see this. Wrong one. Keep popping up in my wrong notes. So if we did this, string is equal to bad, then inside the computer, inside its RAM, are 3 values followed by a 4th value, which is just a 0. And so the 3 values are a 65, a 66, because that's what a B is. I'm not going to zoom in the ASCII chart, just trust me on that. So it would be followed by a 66, and then an A is a 65, and then a D is a 68. And then it's all summed up with a null. So that's what a string looks like to the computer. So this is not a number. The computer can't do anything with it, even if it looks like a number. If we do string is equal to 12, we can't do, we can't use that 12 in math. We can't multiply it, I is equal to S times 10 to equal 120. No, that's not going to work. Why? Because what's a 12 stored behind the scenes? Well, a 1 is an ASCII value of 49. A 2 is an ASCII value of 50. And then it's followed by a 0. Okay, that's what's stored, the bytes that are stored inside the computer. How would it multiply that by 10? And the answer, it can't. That's what you use parse for, Tryparse, to convert a string to a number that you can then do math on.
So I'm guessing that's what I didn't know. It's like C# has a read line function, but the read line function does it like how we have in Java, how we have next double, next int. It's like we have ones for specific primitive data types, but C# just has read line, and then you parse it? Is that what
Right,
you're
right. Some languages give the scanner class in Java give you a whole bunch of different options for reading in ints and doubles and stuff like that. And then others just assume that you're going to read text and you have to do the conversion yourself. And Python is one of those. And C# also gives us, the read line, which returns a string. And I approve of that actually, because if you're getting data off the internet, it's going to be a string. If the user has typed in something in a form, it's going to be a string. You just need to be used to converting it yourself. So this wouldn't work because S is not a numeric value. You would tryparse it to turn it into numeric data to do math on. So an escape sequence. Some characters cannot be represented by a letter. The ASCII chart has a whole bunch of things that aren't just letters, like a line feed or a tab, things like that. Those are represented by escape sequences. Escape sequence is a silly term. The backslash means, okay, we're not going to treat this like ordinary text. And the most commonly used one is just \n. So if you do this, display.console, right, hello, \n. This is a series of characters. That's one character, two characters, three characters, four characters, five characters, 6 characters. The \n is stored behind the scenes as whatever the ASCII value of a new line is. And when you print it out, it'll print out hello, then it'll go to the next line. There are other ones. There's /t, which does a tab. Some languages, some consoles support B for backspacing. I bet there's a chart of them on the next page. /0 for null, /a for alarm. I wonder what that does. B for backspace, F for form feed. I don't know what that does if you're printing things on a screen, but if you're sending them to a printer, then a /f would cause it to kick out a page. It's just a new page. And then there's new line. We don't differentiate between new line and carriage returns, but some operating systems did. Every time you hit new line, it assumes it's doing a carriage return, going back to the beginning of the line. And then horizontal tab, and I have no idea what a vertical tab would do. So some of these are a little bit odd. Why do you need an escape sequence to mean a single quote? Why do you need an escape sequence to mean a double quote? It's in case your string has to consist of that stuff. So if you do S is equal to my name is quote Slim Shady, end quote, that's actually not valid because this is all treated as one string. And then all of a sudden, we have this word slim coming out of nowhere. So this is not valid text. It's not a valid string assignment. It would get flagged as an error. You could fix it one of two ways. One is you could just substitute single quotes there. But if you need to have double quotes because the customer said, I don't like apostrophes, I want you to use double quotes, then you would need to turn these into escape sequences. You put a / there that says, okay, I'm reading this. Okay, what's coming up next is a special character. Okay, I'm going to treat this like it's a double quote when I print it out. And when it printed out, we would see my name is Slim Shady, like that. But it would have quotes around it. We couldn't just type this. We couldn't just type the double quotes. It would treat that as a syntax error. So we need to prefix the / for each one of those. You could do the same thing with single quotes. You don't need to do that in a string, right? Because if you are already in a string, single quotes are okay. If you wanted to do S is equal to my name is Bob, Bobby Roberts, like that, that's fine. You can mix single and double like that. But if you had to put a single quote inside of a character, char ch is equal to, those are 3 apostrophes. Is that going to work? No, because it's going to think that's the open apostrophe, that's the closed one, and then that there's a third dangling syntax error there. So To get that to work, you'd have to put the backslash in front of it, but when it got printed out, it would treat that as though we're the apostrophe character. So using the char data type, characters are actually stored in Unicode. The letter A is stored as zeros and ones. It's stored as the binary representation of 65. 16-bit numbers are difficult to read, so programmers often use a shorthand in base 16, where you have 16 different digits, 0 through 9, but you also have A through F. And this does not go in to explain what hexadecimal is. I've missed it, lost it. So we do need to know what hexadecimal is, but I'm not going to lecture on it this time. Google it up, and maybe we'll have another lecture on hexadecimal. Hopefully you've had a prior class that also talked about it. So the letter A can be represented like that. It can also be represented by its Unicode value, /U, meaning this is it, whatever's coming after it's a Unicode, and followed by 4 hexadecimal digits. And if we go and we look on our ASCII chart that we had open a little while ago, a 41 hex is a 65 decimal, which is an A. So both of these are valid representations of a capital A. So the string data type is a series of characters. Now, unlike Java, you're allowed to compare them directly. Or you can use equals. Java totally chokes if you try to use equal to compare 2 strings. It's only comparing addresses. So you just have to flip your brain a little bit. I'm using C#. It's okay to use equal and not equal. I'm using Java. I have to use the dot equals method. If you need to sort strings, you can compare them. Greater than, less than. That does it lexically, which means alphabetically. Z's are greater than A's. Also, lowercase z's are greater than uppercase z's, according to the Unicode ASCII character chart, which is confusing. But the string data type, here we go. Name 1 is equal to Amy, name 2 is equal to Amy, name 3 is equal to Matthew. Right line, compare name 1, 0 to name 1. Compare name 1 to name 2. Are they the same or not? So name 1 equal to name 2. Are they the same? Yes, they are. So it's going to print out true. Now we're going to compare name 1 to name 3. Are they equal? No, they are not equal. So our output would be true on the first one and false on the second. String equals does the same thing. You can string equals 2 strings. Honestly, I don't know why you would use string equals as opposed to just using 2 equal signs. I'd go with 2 equal signs. However, string.compare does something a little bit different. It returns a 0 if they are equal. It returns a negative value if they are different, but one is comes before the other, and it returns a positive value if one is after the other. So if we look up here, if you compare Amy to Amy, string.compare will return a 0. But Amy becomes before Matthew. So if you do string.compare Amy and Matthew, it'll return a negative number. And then if we compared Zachariah to Matthew, Z's come after M's, so string.compare would return a positive number. So string.compare value A, B returns true if A is equal to B, returns false otherwise, right? No, that's equals. String.equals. String.compare AB returns 0. I cannot type. If A is equal to B, returns negative if A is less than B lexigraphically, meaning alphabetically. And then if you're comparing numbers to letters, how does it do it? Well, numbers are smaller than letters in the ASCII and Unicode charts, so a number would be less than a letter. And then returns positive 1 if A is greater than B. So you wouldn't use string.compare unless you were actually trying to order things somehow. Otherwise, you could just use string equals. And if you're going to use string equals, you may as well just do A is equal to B, in my opinion. But if you want to avoid that because Java has trained you that you can't do that, then go for string equals. So what is a string? It's a series of letters of characters. And you can extract substrings from them. A substring meaning a partial string. So we know if we're programmers that computers start counting at 0. This is position 0, position 1, position 2, position 3, position 4. If we want to just get the W out, we can say word.substring 0, 1. That means starting at the position 0 and going up to but not including 1. So it's equal to W. 0, 2. Start at 0 and go up to but not include 2. So that would be WA. 1, 2. Start at 1, go up to but not include 2. So it would just be, this is wrong. Is it not?
I'll try it.
Well, let's open up Visual Studio and find out. Ah, excuse me. I forgot. This language's substring function, the second one is the length, not the ending position, as opposed to Python, Java, and things like that. So starting at 0 and going 1 character is W. Starting at 0 and going 2 characters is WA. Starting at 1 and going 2 characters is A and T. Starting at 2 and going 3 is TER. If you go from 0 and include the entire word.length, you get the entire word. And you get an error message if you try to go beyond the end of the string. So going from 3 and saying 4, it would try to get ER and then 2 characters that don't exist. So that would produce an error message. So that's worth noting in our notes. S is equal to Darth Vader. And then if you do S1 is equal to S dot substring, and you say start at position 0 and go 3, then that's going to equal dar. If you do S2 is equal to S dot substring, starting at position 3 and going out 5 characters, 6 characters, well, what's character 3? That's 0, 1, 2. It starts with a T, and now it's going to go out 6 characters. 1, 2, 3, 4, 5, 6.
So including the starting character.
Yep. Like that. And I kind of have a fundamental disagreement. There ought to be a function that also returns them using the other style, where you're specifying the starting and the ending position. And why do I say that? Because it's real hard for me to determine whether this is going to be past the end of the line or not. I have to add this one to this one and then check to see if it's greater than length in order to avoid getting an out of bounds error. That is what it is. I'm sure there are reasons to do that. So a named constant is just a constant that has a name. What does that mean? In my code here I typed S is equal to Darth Vader. Well, Darth Vader is a constant. Nothing is ever going to come in and put an exclamation mark there between that unless I physically edit the code. I guess you can't physically edit bytes, but anyways, you know what I mean. You would actually have to edit the code in order to change that. So this is an unnamed constant. It doesn't have a name. We're storing it here. But if we want to make it a named constant, we can do so. So enumeration. What you do with enumeration is to give a series of values. We're declaring a variable type called day of week. and we're saying that day of week can only be set to any of these 7 values. And if the programmer tries to set a day of week variable to anything other than these variables, then it doesn't work.
Enum's always, like, I guess the variable declaration or variable name, is it always supposed to be capitalized or what? Because how it's day of week, but the variable's capitalized, I didn't know if that's just like a standard for.
Seems like it's a standard for C#. It's not a standard for other languages. So you just have to decide whether you're going to capitalize it or not. You certainly don't have to. I need to start Visual Studio so that we can actually play with a few of these things. I'm going to start a new project, and then we should switch over to actually doing the short assignment. Maybe we'll skip the short assignment this lecture. I kind of didn't like the way it turned out anyways. So let's make a console application, and let's declare an enum. Enum, come on, zoom in, colors,
Should Visual Studio get cranky with you too?
so you give the enum, you give the new type you're declaring, and then you give a list of possible values for it. So enum colors, and my 3 colors are red, green, RGB, and blue. Now I think I've chosen something that already exists. Colors may have been a really bad term. No, that one went away. Close quote expected. Why are you yelling at me about that? Int x is equal to 0. Okay, I'm getting little errors there. I'm going to go and read the next slide to see if all becomes illumined. So by default, enumeration values are integers. So behind the scenes, each one of these is assigned a different integer value. But you can specify otherwise by including a colon and a type name after the enumeration name. If you don't supply values, they start at 0 and increment by 1. So if you cast a day of week to an int, then Sunday is going to be a 1, since they said equals 1. Monday is going to be a 2, Tuesday is going to be a 3, Wednesday is going to be a 4, and so on. Programmers say that using enums make the values type safe. Type safe describes a data type for which only appropriate behaviors are allowed. So we didn't get an example of a C# enum there. Google one up. Okay, so an enum wants to be declared outside of main. That was my mistake. So I'm going to go back to my code, take my enum here, and it's a class member. So enum, not infinite number exception, enum colors. Still not sure why I'm making that uppercase. And then red, comma, green, comma, blue, like that. It's a little bit different than C, where you can go nuts declaring your my mistake again. I don't know why I'm putting quotes around everything. I was trying to define it as though it were a list. There we go. Alrighty. So we now have our new data type called colors. And so if we wanted to, we could do colors, my color equals red. Nope, you have to do colors.red. So you have to give yourself a scope for what the value coming up after it is. Colors Now I'm thinking that it ought to just be called color, right? Because, you know, just like an int is not ints, it's not plural. And I'm also wondering why I chose uppercase, because that makes it look like a constant. So I'm going to follow the book standard of renaming this with an uppercase letter, the rest lowercase. And then it looks like this. Color my color is equal to color dot red. And color your color equals color dot green. What happens if we display this? Console dot write line and then just write out my color. The answer is that it's not going to print out the word red.
Something out of a 1, right, or something.
Yeah. So console dot read key, just so that it hangs out after I've run it. Well, what do you know? It did print red. Well, blow my mind. My mistake. I guess I should have done this before I started the lecture. But it's got an integer value. So if you do this, int I is equal to color.red, and then we print it, we're going to get an error because this is not an int, is it? It's a color. But you could get the integer value out of it by casting it like that, right? Yeah, there you go. And so if you printed out I, it would print out that red was a 0. Console dot write line I. It's going to print out 0. And it would print out 1 if we chose green. It would print out 2 if we chose blue. In Java, you have to go through all sorts of hoops to set up equivalencies between these integer values and strings. And so C# is really cool in that respect. I'm doing that for you. All right, so say we didn't want R, G, and B just to equal the values 0, 1, and 2. So you could say an R is equal to a 10, a G is equal to a 20, and a B is equal to a 30. Why would you need to do that? Why would you care? Well, you may need to be writing this out to a file in a format where you're not going to actually write the words RGB, I mean red, green, and blue out. You need to store them as numbers, and then you can read them back in. So we're just assigning different values there. Now if I run it and I print out the value of I, since I is the cast version of color.red, it will say that I is equal to 10. So the characters can be assigned to a string. No, wait, that's totally different. But we saw that. We saw it get auto-converted to a string on its way out. So does that mean that we can do this? Can we do string C or S is equal to color.red? Didn't think so. Can you cast it? Wouldn't think so. Okay, so there's got to be a way to convert that to a string. Color.red.toString. That's how it works. What do you know? Okay, now when we print it out S, it actually is a string. So what's going on is when we print it out, implicitly is calling the toString method on that data type. So right there, when we print out my color, write line is expecting a string, but in this language, everything is an object. Everything has a toString method. So it calls the toString method on my color to get us our text out. So it'll print red.
So that's weird. So like you can't cast it as a string, but you can still convert it to a string.
Right, you can convert it to a string. And it makes sense. I absolutely did not expect casting to work, because a cast is supposed to be a mathematical transformation from one to another. And so there's no mathematics involved in taking the word red and turning it into the letters RED. So why is that good? Well, if you ever find yourself in a case where you're coming up with data and you're saying, okay, well, I'm going to let the user pick from a series of values, and they're going to pick whether they want, overnight shipping or 2-day shipping or whatever. And so in your code, you wind up saying x is equal to 3, and if x is equal to 3, then do overnight shipping. Instead, you want to use enums for that kind of stuff, so that if it's impossible to set x to anything other than the listed values. So an interactive program, read line, pauses, lets the computer type in something, and is saved as a string. Then if you need it to be something else, you have to tryparse it. Suddenly I have the question in my mind, can you tryparse a string to turn it back into a color? So if we do this, s is equal to console.readline. This is just experimenting. Let's put a print statement above it so that they know what they're supposed to do. Console.writeLine. Enter red, green, or blue. Now let's try parsing it. Let's make a new color. Color, their color, or just theirs. And then bool, be okay, is equal to if I got the syntax wrong, is it all lowercase?
Double.tryparse.
Okay, yeah, but it's not a double.
String.tryparse.
Color, this is not going to work. Dot tryparse? Nah. Okay, so we can't do that. Which is something you'd like to be able to do. I'd like to be able to turn that string back. There's got to be a way to do it, but I'm not going to spend time fumbling and taking a stab at it. So why don't we just delete those 3 lines, since that was a failed experiment.
I put string.join.
So we have all sorts of ways to convert. Convert.toDouble. Convert.toInt. The problem with that one is that it'll blow up if it's incorrectly formatted. And that's why we use tryparse. So for example, if I'm in my code and I say string is equal to 12 blah blah blah, and then I say I is equal to convert to int 32, parentheses, that string. This should not work because you cannot convert 12, D, F, J, whatever.
Didn't stop you. Oh, yeah.
An unhandled exception of type format exception occurred. So it just flat out didn't work. So we should have used tryparse there, integer.tryparse. That would be the bad way to do it because crashes program. That's not a good way to do it. Generates an exception since s is not a proper int and can't be converted. So instead, bool OK is equal to integer dot tryparse int.tryparse, pass our string in, and store the result in I, so out I. And it's supposed to be bool okay, not book okay. And then if okay is equal to true, then we have a valid value. So steer away from using this convert, unless you're sure that you have good data. Unfortunately, it's got all sorts of niceties built in. Int 64, 32, 16 to a string, so on. But you can use, you know, int.tryparse or double.tryparse or long.tryparse or whatever in order to handle all of these cases. Convert to string. That's interesting. Okay, anyways. The parse method. It's the alternative to convert class. It means to break it into its component parts. It turns a string into a number equivalent.
Oh, so if you try to parse that and run it, it should work?
Well, OK is going to equal false.
Yeah.
And in that case, the value of I is what I would call undefined. We don't know what it is. But let's go ahead and write it. Console.writeLine BOK equals placeholder 0, so curly braces 0. I equals curly braces 1. And then pass in OK. And then pass in I. I said BOK, but our variable name was just OK. So I'm going to change that.
So it equals 0.
I have my read key up here interfering with things. I need to cut that read key and put it down at the very bottom of my code. So I have done that. I took read key, I put it down at the beginning. So did it reset it equal to 0? What was I before we went in there? I is equal to 99, and now I'm going to run it. Okay, so if it fails, it sets that variable to 0, but you wouldn't want to use that because they may not have typed 0, you know, or they may have typed 0 and it might be valid data. So you can't just say if I is equal to 0, I got an error. Instead, you base your error based on the return value of the tryparse function. And this is the kind of slickness that C# does that Java does not, where you can pass in a variable and then the return value comes straight back out of the parameter. So Java is not a pass by reference language. It's a pass by copy. It's a pass by value. So you get to do things in C# that you can't in Java with respect to changing the values of parameters and having those things come back out. And that's what the out word means, is that, oh, by the way, this function is going to be changing I. I is going to be passed back out, and it could be different than what it was when it came in. So this is kind of a recap. Variables and constants use data types to hold data. A constant cannot be changed in the code after it has been assigned. So if you say const pi is equal to 3.4159, then nothing is going to change it. All right, why don't we just stop here, and then we will come back and we will do a tutorial after this. So I'm just going to make a Dropbox, and you can upload your CS file, or you can just upload a text file saying, yes, I watched it. And we will get back together tomorrow and continue our lecture.
3 or 2?